Hey gang, welcome to week 5 of Code Club Year 2. This week, we're going to add some objectives for our hero, which are coins to pick up and spiders that can be the hero's enemy. Open up another browser window and log on to Cloud9 so that you can follow along. Have fun and let's start coding. Now that we have a hero in our game who can move around, he needs an objective. So we're going to add some coins for him to collect and some enemies, which are going to be giant spiders. Both of these things are added using what's called a sprite sheet instead of just a standard single image. And if we can actually look at a sprite sheet here, here's the one for a coin. Basically what it looks like if you took an animation, and this is an animation of a coin rotating, and blew it up and put every frame of that animation into a single image. The same thing with the spider. We see the first 3 kind of make it look like a spider is walking around, and the last 2 kind of make it look like the spider is dying. So a sprite sheet is like this animation that gets exploded, and you can tell Phaser which frames of the sprite you want to use essentially, and it will use those to create an animation. This type of animation, where it's based on sprite sheets, is usually called keyframe-based animations. We're going to start by adding the coins to the game, and the way we do this, just like everything else, is we need to add the asset into the game cache first. And we do it almost exactly the same as how we loaded images and audios in our JSON file. We need to tell it a name, we need to tell it a image that we're going to use. The differences are we call it a sprite sheet instead of an image or audio, and we have to tell it how big each frame of the animation in the sprite sheet is. So in our coin file, each frame of the animation is 22 by 22. And Phaser will use this as it switches between the frames of the animation to know where to go next. Just like heroes and platforms, coins are listed in our JSON file. So there's a list of coins, and each individual coin object has an X and a Y coordinate listed. And then also, just like platforms, we want to add the coins in a group. So the way we're going to do this is in load level, we're going to create a coins group, just like we did with platforms. And the other thing we're going to do is that for each coin from the JSON file, we're going to call a spawn coin function. And this, again, it works just like platforms. It's going to say for each coin in the JSON file, call a spawn coin function. Because we're calling a spawn coin function, we need to add that function to our game because it's not there yet. So we're going to scroll down to just under spawn characters and create the spawn coin function. And the spawn coin function does several things. It loads the coins out of the JSON file at their proper X and Y positions, adds an animation to the sprite sheet and starts it playing, and then enables game physics but disables gravity so that the coins and the heroes can collide. In this code, the animations add and animations play lines are the ones that actually make the animation start for the sprite sheet. If we look at add, there's several parameters that get passed into that function. So the first one is just a name. We're going to name the animation rotate. The second one, which is this list of numbers in between the brackets, remember brackets make it a list, those are the frames of the sprite sheet and what order they should play in. So if we look at the coin animation, it's going to play in the order 0, 1, 2, 1. That's what our animation is going to look like. The parameter 6 tells it how fast to go, and 6 means 6 frames per second. And then the last one, true, tells add that we want that animation to play over and over again. So it's just going to keep going. Frame 0, 1, 2, 1, 0, 1, 2, 1. It's going to play those animations over and over again. Now if we save the code and go back in here, you'll see we have coins and they're in the right positions from our JSON file. But our hero can't actually interact with them yet because while physics is turned on for the coins, we don't have any sort of collision function between the hero and the coins like we do between the hero and the platforms. Let's go back and add that collision function. Right now in handle collisions, we only handle the collision between a hero and a platform. We're going to add a new line of code that handles the collision between hero and coins. So the first thing you'll notice is this is a different type of collision. It's called an overlap. And so what that means is when a hero and a coin overlap, do something. And we're going to tell them to do this on hero versus coin function. So when a hero overlaps a coin, call this function. Of course, on hero versus coin is a function that doesn't exist yet, so we need to add it. We'll just add it right at the bottom of the file. We'll add on hero versus coin, and it gets a hero and a coin passed into it. And all we're going to do is have it kill the coin, which makes it go away. It's no longer on the screen, no longer part of the game. We'll make the coin do more interesting things when the hero interacts with it later. If we save this and go back and look at our preview now, every time the hero hits a coin, the coin goes away because we're saying the hero versus coin kills the coin. Wouldn't it be nice if when our hero picked up a coin, it made a sound just like when our hero jumped? We can add that too. The code is going to be very similar to how the code looked for when we added the jump sound. So I'm not going to go into too much detail, but I'll go through it real quick for you. The first thing we need to do is preload the sound just like we preload all of our other sounds. Then we need to create the sound within the game world. And remember, when we're adding to a list like this, we need to add a comma at the end of the previous line, and then we can add our new line. So we added a comma at the end of the jump, and then we added the coin sound, calling the coin preloaded file that we loaded up here. Finally, at the top of our on hero versus coin function, we'll add a line of code that actually plays the coin sound. Now if we save our file and go back and look, every time we pick up a coin, it plays a little sound. Like I said at the beginning, our enemies are going to be giant walking spiders, and we're going to create those using techniques that we know from all of our other object types right now. We're going to use groups just like we use with platforms and coins. We're going to use sprite sheets just like we use with coins, and we're going to create a new spider type of object by extending the sprite prototype just like we did with the hero. And just like all of our other object types, the initial location of each spider is going to be loaded from the JSON file. The first thing we need to do is preload the sprite sheet for the spider. And if you look, it's loading a spider image, but at the end where we tell it how big the spider animation frames are, it's very different than the coins, and that's because they're different animations. They have to have different sizes. The next thing we're going to do is add the code that creates a spider object. And we're going to do this right after our hero object code. So right here, right before var play state, we'll put in the spider object creation code. And there's several different things happening here. I'll walk through it real quick. So the spider object calls the constructor for the sprite object, just like our hero did. It adds two animations. The first one is a crawl animation that goes through frames 0, 1, and 2 at a speed of 8, and it repeats itself. The next one is a die animation that goes through frames 0, 4, 0, 4, 0, 4, 3, 3, 3, 3, 3. So it goes through those things at a speed of 12, but it does not repeat itself. And then it starts the crawl animation playing, but not the die animation. We're not going to start that one playing until the spider actually dies. Then we're going to enable physics, and we're going to have the spiders collide with the world boundary. You'll notice I didn't disable gravity for these, and that's because if a spider should happen to fall off the side of a platform, we want it to actually fall off. And we'll deal with that a little bit because we don't actually want them to fall off the sides of platforms, but it's available to happen if we want it to happen. Just like with coins and platforms, we want the spiders to be in a group so it's easier for the hero to interact with them. So down in low level, we're going to add the code to put the spiders into a group. We also need to make the spawn characters function know that we want it to spawn spiders as well. And the way we're going to do this is right now we just say hero is data.hero. That's what we're saying right now when we pass data into spawn characters. What we're going to add is this part of the code where we add a comma after hero, and then we add spiders is data.spiders. So now our spawn characters function is going to get a list of our hero object is the hero data from the JSON file. Our spiders objects are the spiders data from the JSON file. But spawn characters doesn't actually know what to do with that data yet. So we need to scroll down to spawn characters. And we can add some code in. And this is going to say, for each spider that gets passed in the data, create a new spider object as a sprite and add it to the group of spider sprites. If we were to save and reload at this point, we'd have spiders on our screen, but they don't interact with the platform, so they fall right off. To fix this, we're going to add a little bit of code to handle collisions, and that little bit of code is just going to tell spiders and platforms to collide. So if we refresh again and go back, now the spiders stay on their platforms until they reach the end and then they fall off. So we need to fix that as well. To fix this problem, we're going to add some invisible walls at the end of each platform. So they'll be like right here and right here. We won't be able to see them in the game, but because there's something there, they'll be able to interact with the spiders and stop the spiders from falling off of the platforms. The invisible walls are just going to be another sprite, which means they need an image attached to them, even though we're not going to see it. So the first thing we need to do is go up to preload and just add a preload of an invisible wall image. And we want the invisible walls to be in a group so they're easy to collide with. So in load level, we'll add a new group called enemy walls. When we want to create the walls, we'll do it as part of the platform creation process instead of having to keep track of the invisible walls in the JSON file, because that would make it difficult to tell where the platforms are in relation to the invisible walls. Instead, in spawn platforms, we're going to add these 2 lines of code to create the enemy walls. The first line of code creates the left platform. The second line of code creates the right platform. The way it works is they're going to call a new function that we'll need to create called spawn enemy wall, and then it passes in parameters for what the X and Y coordinate of the platform are and whether it's the left or the right platform. And for the left platform, we just pass in the current X and Y coordinate of the platform, which will give us the bottom left corner of the platform. For the right platform, we're going to pass in the current X coordinate, but also add in the width of the current platform, and that'll give us the bottom right side of the platform when we spawn the enemy wall. Now we need to create the spawn enemy wall function so that the walls actually get created. So down underneath spawn coin here, we'll create a new spawn enemy wall function. The spawn enemy wall function is very similar to the other spawn functions that we've created so far. We create a new sprite that goes into the enemy walls group, and we enable physics for it, but we make it immovable and we disable gravity. That's very similar to all of our other ones. We, enable, disable gravity and game physics and that kind of stuff. The big difference here is the sprite anchor set function. If you notice in most of our other ones, we do it similar to this where it says sprite anchor set 0.5, 0.5. Phaser uses the anchor when we tell it to move a sprite. It moves the anchor of the sprite to the X and Y coordinates that we set. The default anchor is 0, 0, which means move it to the upper left corner of a sprite. When we use 0.5, 0.5, like we do in a lot of our objects so far, that means to move the exact center of the sprite to the X and Y coordinates that we said. What we're doing here in spawn enemy wall is we're saying this weird line of code for where it says side equal left 1 and then colon 0 and then comma 1. It looks really weird. What it's actually saying is when the side, remember we're passing in a side variable for whether it's the left side or the right side. So if the side is the left side, set it to 1, 1. If the side is the right side, set it to 0, 1. And what that means is if it's the left side wall, we're going to set the anchor to the bottom right side. If it's the right side wall, we're going to set the anchor to the bottom left side. And when I show you the preview of what this looks like, you'll see what it means to have it be the left side or the right side. The reason this looks so weird is this is using what's called in JavaScript a ternary operator. And it's a shorthand way of using an if-then-else statement. So it's saying, if the side is left, set this to 1. Otherwise, set it to 0. That's all it's doing. It looks really weird, but it's a pretty standard operator to be using sometimes in JavaScript. Really quick, before I preview this for you, I want to add a collision function between the spiders and the invisible walls so that you can see what happens with them. Now, if we save and look at our preview, we have these pink walls and the spiders run into them. Now, if you remember, I said that we set the left side anchor to be the right side of the wall, and that's how we get the wall to line up with the exact left side of the platform. And the same thing over here, we set the right wall anchor to be the left side of the platform, and that's how we get it to line up with the exact end of the platform. Obviously, we don't want to see these pink walls in our game, so if we go back to our code, in the load level function, right after we create the enemy walls group, we're going to say enemy walls are not visible. So we have a Boolean variable here called visible. We're going to set it to false, which means enemy walls are not visible. So now if I reload, look at the preview again, now there's no enemy walls, but the spiders still stop at the end. We don't want the spiders to just stop when they hit those invisible walls, though. What we'd really like is to have them move back and forth along the platform, and when it hits the wall, turn around and move back the other direction. The reason right now that it's just stopping is we're using a collide function, which is the default built-in phaser collision, and all it does is stops the objects instead of allowing them to continue moving. We're going to handle this by adding an update function to the spider object. So if we go all the way back up to the end of where our spider is being created, we're going to add a new function to the spider called update. And because it's called update, Phaser knows it's special. And this is one of those things that's going to get called 60 frames per second really, really fast. A lot of calls to this function. And what it's going to do is if it's going to do this if test that says, if the right side of the body is touching something or the right side of the body is blocked on something, change the spider's speed to the opposite of its current speed. And then it's going to say if the left side is touching something or the left side is blocked by something, change the velocity to be its normal speed, not the opposite of its normal speed. And what you do is when you set the speed to the opposite, it just makes something go backwards. So if it's touching something on the right, it's going to go backwards. If it's touching something on the left, it's going to go forwards. Next week, we're going to make the spiders and coins a little more interactive. And that is going to be, we're going to make it so that if a hero touches a spider, either the hero's going to die or the spider's going to die. And we're going to add a scoreboard so that as we collect coins, they get added into a scoreboard. Alright, that's it for this week of Code Club Year 2. I hope you enjoyed it. We'll see you next week.